Coral reef destruction and marine ecosystem. What is coral reefs? Coral reefs are underwater structures made by tiny sea animals called polyps that form complex ecosystems. Coral polyps and zooxanthellae, microscopic algae, have mutualistic relationship that benefits both organisms, and also polyps provide sunlight and protection. We have the largest coral reef, the Great Barrier Reef. We can find it in Australia. Red Sea Coral Reef. We can find it in Israel, Egypt, and Djibouti. New Caledonia Barrier Reef. We can find it in South Pacific. Mesoamerican Barrier Reef. We can find it in Atlantic Ocean. The Florida Reef. We can find it in Florida. The Andros Coral Reef. We can find it in Bahamas. And the last one is the Saya del Maha. We can find it in Indian Ocean. The main stressors for coral reefs are overfishing, removes key species to taking out large predators, like sharks, disrupts the balance of the reef ecosystem, and reduces herbivores. Fewer herbivores, fish means algae overgoes mothering corals, and climate change. Coral bleaching, rising ocean temperature, cause coral to expel the algae. They rely on the food, leading to bleaching and eventual death. Ocean acidification. Increased CO2 in the atmospheres makes the oceans more acidic, hindering coral growth and making them more fragile. Pollution. Nutrients runoff, fertilizers, and sewage cause algae blooms, blocking sunlight and suffocating corals. Sediment runoff. Constructions and deforestation lead to increased sediment in the water, smothering corals. Chemical pollution. Industrial waste and oils spills in poison of coral reefs. These traits interact and compound each other. Overfishing weakens the reef's resilience, making it more susceptible to the impact of climate change. Pollution further stress weakened reefs, reducing their ability to recover from bleaching event. Coral reefs also are affected by linking fuels, anti-fouling paints, and coatings, and other chemicals. Coral bleaching is a phenomenon that occurs when coral expels the algae that live in their tissues, causing them to turn white. Bleached corals are not dead. They are more vulnerable to disease and starvation. If the condition that caused the bleaching remain extreme or prolonged, the coral may die. Cause of coral reef degradation. Global warming is causing sea levels to rise, threatening coastal pollution centers. Natural disasters not only events that cause the stress among coral reef. Humans are also the problem. Examples: dynamite fishing. Explosions shatter coral skeletons, killing massive number of fish and invertebrates instantly. Overfishing. Healthy fish population help control algae growth, a crucial function for coral survival. And dredging. Stirred up sediment smothers corals, blocking sunlight they need for photosynthesis. And the last one is pollution. Chemical pollutants, industries waste and oil spills poison corals and other marine life. Impact on wildlife. Coral reefs are home to about 25% of all marine species, providing habitat, food, and breeding grounds. When reefs are destroyed by factors like coral bleaching, overfishing, or pollution, species such as fish, crustaceans, and mollusks lost essential habitats, leading to reduced biodiversity. The climate change, pollution, fishing practice, coastal development, recreation misuse, and natural phenomena can impact on the wildlife. Impact on human health. The destruction of coral reefs harm human health in two main ways. 1. Less food. Reefs are home to many fish that people depend on for protein. When reefs degrade, fish stocks decrease, leading to malnutrition, especially in communities near the coast. 2. More damage from storms. Coral reefs act like natural walls, reducing the impact of the storm surges. Without them, flooding and erosion become worse, affecting millions of people globally. Economic impact: depletion of fish stocks. The destruction of coral reefs lead to decline in fish stocks. Second, loss of ecological services. When coral reefs die, services such as water purification and bleached sand production decline, resulting in additional costs for local communities and governments. Third, shoreline protection. Beyond their biological value, the physical structures of coral reefs reduce wave energy, wave heights, and associate with erosion and storm damage. Fourth, loss of livelihoods. A decline in fish stocks can lead to economic hardship and food insecurity. Fifth, impact on local businesses. A decline in tourism can have ripple effects on the local economy. And the last one is loss of biodiversity. Coral reefs are incredibly diverse ecosystems supporting a wide range of marine life. Percentage breakdown of reef threats and importance. Coral reef percentage past 30 years is 4.10%. Fish stocks fully exploited or overfish is 4.90%. Coral reefs at immediate risk is 3.30%, and people relying on coral reef fisheries is 82%. Current statistic: climate change. Temperatures rise by more than 1.5 Celsius above pre-industrial levels. We could lose up to 90% of coral reefs. Ocean acidification. Ocean acidification could reduce calcification rates by up to 30% by the end of the century. Pollution. Pollution is responsible for degrading over 60% of coral reefs ecosystem globally. Current efforts to combat the problem. Marine Protected Areas (MPAS), where human activities are least partially regulated to conserve marine biodiversity and sustain ecosystem services. Restoration Project: rehabilitating degraded system, enhancing biodiversity, and improving ecosystem services. Combating climate change: reduce the damage it gives to coral reefs and marine ecosystem by transitioning into renewable energy instead of using the non-renewable energy. Sustainable fisheries management: establishing scientific basis for catch limits, reducing the numbers of seasons when fishing is allowed. Public awareness and education: emphasizing education is the key to success of the INIPAST Act. Policy and global management: mandates a major overhaul of the funding of the staffing are supposed to make these areas protected. Innovative solutions: coral restoration, cultivating coral fragments in nurseries and transplanting them onto degraded reefs. Climate change mitigation, transitioning to renewable energy resources to reduce greenhouse gas emission and slow climate change. Ocean acidification mitigation, adding alkaline substances to coastal waters to buffer against ocean acidification. Technological innovations, creating artificial coral structures to mimic natural reefs and provide habitat for marine life. And community engagement and education, establishing and enforcing marine protected areas to limit human impact on coral reefs, and promoting sustainable fishing techniques to reduce overfishing and bycatch. Challenges in solving the problem: climate change and global warming, estimated 90% of the excess heat produced by climate change warming gases. Overfishing and unsustainable fishing practices. Bycatch, or the capture of unwanted marine life while fishing for another species, is closely related to overfishing. Pollution and habitat degradation. Marine debris, especially plastic pollution, harms marine animals through ingestions and entanglement. Limited political will and governance. Weak international institutions and disorganized policies. Actions individuals can take: reducing carbon footprints, burning fossil fuel causes oceans warming and acidification, which harm coral reefs. Avoiding coral souvenirs. Some products like jewelry or decorations are made from coral. Buying these items harms reefs by depleting coral biodiversity. Practicing responsible recreation. When visiting coral reefs for activities like snorkeling or diving, participating in community efforts, supporting local and global efforts to restore reefs can make a big difference. Sustainable seafood choices. Avoiding eating fish caught in ways that harm coral reefs, such as overfishing or destructive fishing methods. Local engagement. In Philippines, community-led marine protected areas are helping reefs recover. Coral reefs, known as the rainforest of the sea, are facing significant threats from human-induced and natural factors. To address this, a multifaceted approach including reducing greenhouse gas emission, implementing suitable fishery practices, reducing pollution, and establishing marine protected areas is needed. Public awareness campaigns and educational programs can also contribute to a sustainable future. Thank you for listening and mabuhay.